Okay, so the scope of MEP, we all know that the scope of MEP is for all the building, and in this we are going to have a look of what is electrical designing and drafting. So whatever the thing which we are studying in this electrical design drafting is not only applicable for residential building, it is applicable for commercial building also, and it is applicable for the industrial building also. Okay, so because the concept of calculating the things is same for might be a residential or might be a commercial. That is nothing but electrical design drafting. What we are going to learn in the session is not only applicable for residential, all the buildings, it's the same concepts. So now let us see what is that we are going to study in this electrical design and drafting. Okay, now first of all, what is electrical design and what is drafting? So designing means calculations or the sizing of equipments is called as a design. So in the electrical, we are going to learn about the electrical design and drafting. In that design and drafting, design means calculations or the sizing of equipment is called as an electrical design, and drafting means pictorial representation of all the calculations through a software called as an AutoCAD, where we are going to draw the complete things through a single line diagram, circuit wiring and the control wiring, that are called as an drafting. So design means calculations. Like example, I'll tell you, for a building you got an architecture layout. For that architecture layout you need to do the total load calculations, lighting calculations, then AC calculations, then the transformer sizing, generator sizing, cable sizing. These all are calculations which are called as a design. Okay, so this design is perfect. Design is done based upon the standards of National Building Code or National Electrical Code, and whatever the design which we have done in Excel sheet or software, that we can't give it to a project engineer or site engineer or to a client. Okay, because if you are giving that total calculations to a client, next time he will not ever approach to you for a project, right? So what is that we need to give? We need to give a summary of that. So that summary is being shown in a drawings called as an AutoCAD. That is called as a pictorial representation, that is called as a drafting. So electrical design and drafting we are going to. Now when you are going with the sectors of electrical designing, as I told you, whatever the thing which you are studying, it is not only applicable for residential, it is also applicable for commercial and even for the industrial also, the sectors of this electrical design. Okay, now let us see how the power is going to supply for any buildings. Okay, starting from the generation stations to the end point. We all know that the energy which the power which you are getting it up, obviously it's getting generated somewhere in the generation station. So generation stations are nothing but we have a nuclear, thermal, hydel and power plants. Okay, different power plants where the energy is getting generated. Okay, now whatever the energy which has been generated, what are the power of the energy which is generated, that has to be transferred to a consumer end. So what are the things we have it from the generation stations to the consumer end? So let us look off. So once the power which has been generated, that power has to be transferred to the substation. Why we transfer it to the substation? Because we all know that 99% in India the generation stations are rated at level kV. But if I directly transfer this level kV to the consumer end, there is a lot of distance from the generation station to the consumer end. So because of that reason, what happened? The voltage will be drops. So what is that we are going to do? We are going to give it to the substation. In the substation, we are going to step up or step down based upon your application with the help of transformers. Okay, we are going to put a transformer. With the help of transformer, we either step up the voltage or step down the voltage. So that is nothing but we are going to study about the transformers. And now we all know that in the transformer, the purpose of this transformer is to do step up as well as in step down. So we are going to do the step up of the transformer, step up, as well as we are going to do the step down based upon your required voltage levels. Then transformers, we all know that transformers are classified into three different types according to electrical. The first one is power transformer, second one is distribution transformer, and the third one is we have as instrumentation transformer. So we are going to study in depth about this transformer, power transformer, distribution, instrumentation. Where do we use power, where do we use distribution transformer, where do we apply the instrumentation transformer? Now once the transformer part has been done, then we have a protective equipments. So what are protective equipments? Like circuit breakers, relays and the contractors, right? So we are going to study in depth about the protective equipments, like we have an isolators as well as a switch circuit breakers. Okay, so we are going to study about the isolators as well as in circuit breakers. Now in the circuit breakers, we have a types of circuit breakers like MCB, MCCB, ELCB, ROCB, RCCB, VCB and SF6. So we are going to study in depth about that circuit breakers. Now after this, we have a more equipments called as measuring devices. So what are measuring devices? We have measuring devices are nothing but we have a current transformer as well as a potential transformer. So we are going to study about the measuring devices in which we have a CT and PT, current transformers as well as a potential transformers. So if you want to purchase a CT from the market, we need to give us technical specifications, like on what basis we are going to purchase the CT and PT. So we are going to study in depth about that. Next, once the measuring device has been done, now the supply comes to the main distribution board. Okay, after the transformer, with the help of all these equipments, it comes to the transformer, and from the transformer we are going to do step up and step down, and then we have a circuit breakers, and after the circuit breakers we have a measuring devices which displays the voltage and current. Now once that part has been done, the supply has to be transferred to the MDB, main distribution board. Now what is main distribution board? For a building, the first point of supply where the power from the transformer is coming and connected will be in the main distribution board. Then from the main distribution board we are going to supply to the sub-main distribution board, SMDB, and from the SMDB we are going to supply to the distribution board. So MDB is for total building. What is the purpose of MDB? Is in that we have a bus bar chambers as well as in circuit breakers like ACB or VCB or SF6. So the purpose of this MDB is nothing but if any major problem occur, if any problem occur in the building, if you want to switch off the supply, then we just switch off the supply of the main MDB. So total building power will be cut off. But suppose if the problem occur in the first floor and I want to switch off the supply of the first floor, if I switch off MDB, what happens? The total building will be get power cut off. But if I go with SMD, then that floor problem only, that floor power will be getting cut off. The remaining floor will not be disturbance. Now coming to the DB, DB is for the total flat. Okay, individual. MDB is for building, SMDB is for the floor, and DB is for the individual flat. So that is about that one. Now coming to the design models of electrical design models. So in this, what is that we are going to learn in the electrical design is electrical designs are classified into 6 models. Okay, electrical design models are classified into 6. The first one is basics of electrical design, in which we are going to study only the basics part. And second one is we are going to study about the electrical load calculation for the building. So in the electrical load calculation, we are going to calculate the loads, lighting loads, power loads. In the electrical load calculation, we are going to calculate the lighting loads, power load, AC loads, and we are going to calculate the total current load of the building. Now once we got the total current load, we need to do the load balancing. So that is we are going to study about the electrical load balancing sheets. And after doing the load balancing sheet, you need to give the power supply to that building, right? So who is going to give the power supply with the help of transformers or generators and the UPS? So that is nothing but electrical load summarization. And once we are done the electrical load summarization, we are going to give the power source. Power source are nothing but transformer, generators, and the UPS. And then we are going to study about the electrical design calculations. Means we are going to study about the voltage drop, short circuit, tripping, and all calculations we are going to study in the electrical. And now then building protection system, like we are going to study about the cable trace, bus bars, okay, earthing. This all we are going to study in the last model. So electrical design models are classified into 6 different models. Now let us see what are the topics we have in each and every model. Okay, so electrical power or electrical load. Generally for a building we have a types of loads. We have 3 different types of power, that is active power, reactive power, and the apparent power. We all know that. Okay, just an introduction about the basics of electrical. In the basics of electrical model, we are going to study about the types of power like active, reactive, and apparent power. We all know that active power is rated in terms of watts and kilowatts, right? We have rated active power is rated in terms of watts and kilowatts. Then next is reactive power, which is rated in terms of VAR or kVAR, and the total power, that is nothing but apparent power, which is rated in terms of kVA, right? Okay, next. So what are the examples of active power? What is active power? The one which helps to do the actual work for the system is called as an active power, which is rated in watts and kilowatts. Examples are nothing but you have a geyser, you have a fan, you have a light. These all are called as an active power, right? Next is when you go with the reactive power. Reactive power is nothing but your capacitors, okay, which helps in creating a magnetic field. Okay, for all your inductive loads, we are going to put a reactive power. And the next is we have an apparent power. What are apparent power? The one which is giving a power for your building, that is your transformer, generator, and UPS. So these all are rated in kVA. Only the 3 things in our electrical supply are rated in kVA. That is nothing but transformer is rated in kVA, generator is rated in kVA, and the UPS is also rated in kVA. That are apparent powers. Okay, now I'll tell you a small example. Okay, formulas used for various types of power. So in the basis of electrical design, what is that we are going to study? Is a small example. So generally, if in the electrical, if you want to do anything, first of all we need to calculate the current. Okay, if I calculate the current, then only I can define the remaining parameters. Okay, so how do we calculate current for given loads? Example, I have a load of tube light. Okay, I have a light that some 36 watt to 40 watt. How do we define a current? So people says that Ohm's law, V equal to IR, but Ohm's law is the one which is only used for a small resistor, but not for a particular load, right? So what is the formula we use? So you can see a small example. If the power is active, okay, I'm just telling on a small example only, but in the detail it will be held in the models. So the formula here is we use a formula called P is equal to VA cos phi, or we use a formula called P is equal to root 3 VA cos phi. Okay, so that is P equal to VA cos phi, root 3 VA cos phi. If the power is in active, that is in watts and kilowatts, if you want to calculate the current, then the formula here is P is equal to VA cos phi, where it is single phase, and in single phase we all know that the voltage is 230, and if the power is an active and if it's a three phase, the formula here is P is equal to root 3 VA cos phi if it's a three phase and where the voltage is 415 voltage. So when you're going with the standards of Indian standards IEC, the voltage has been told that the voltage is range in between single phase 230 plus or minus 10% and in a three phase 400 plus or minus 10%. That's about the active power. Now when you go with an apparent power, if the power is an apparent, then the formula here we use is P is equal to VI, and the next is P is equal to root 3 VI. That is for single phase P equal to VI, and for three phase P equal to root 3 VI. So when you're going with if the power is an active, where the value of cos phi is always 0.8, okay, because by default the power which you're going to get it from the government will have a default power factor as an 80%, that is 0.8 as an power factor. We always take 0.8 as an power factor and we calculate the current. So if suppose if the load is an active, how do we calculate the current? We have a formula called P is equal to root 3 VA cos phi, then I need to calculate I, then I will become I is equal to P divided by root 3 into V cos phi, then P is your load, root 3 is a constant value, voltage is nothing but either it's a 415, I, and then next cos phi is 0.8, then you can calculate the current for given loads. Now if the power is reactive, what is the formula? If you are going with the reactive, we have a formula called P is equal to root 3 VA sin phi, where three phase 415 voltage. In terms of reactive, we don't do any calculation for single phase, because whenever you are purchasing any single phase equipments, we are not going to purchase any capacitor separately. It's come with by default along with that equipment. That is P equal, that is, well, we don't do any calculation, we directly get it from the manufacturer. But for three phase, no one is going to give a capacitor, so we need to calculate that. So to calculate that, we have a formula called P is equal to root 3 VA sin phi. Okay. Now the question is, how do we decide whether the given load is single phase or three phase? We had seen a lot of formulas for single phase and three phase if the load is an active or reactive or apparent power. But how we decide whether the load is single phase or three phase? So who has going to give the standards? So in India, we mostly prefer with the standards called NEMA, National Electrical Manufacturing Association. So NEMA has given a certain standard for the manufacturing department that if the load is this, then it need to be considered as a single phase. If the load is more than that, we need to consider that as in three phase. So what is the standard for active power only I'm telling? So what is the standard for active power? So the standard for active power is if it is up to 4 kilowatt, we consider that as in single phase, and if it is above 4 kilowatt, we consider that as in three phase. Whatever the load it is, whether it's a TV or fridge or cooler or a compressor or grinder, generally the loads which are less than 4 kilowatt are considered as in single phase, and if it is more than 4 kilowatt, they are considered as in three phase. That's about the basics of electrical design. Now when you look out for the second model, electrical load calculation for a building, what is that we are going to do in this electrical load calculation for a building? So in the electrical load calculations of our building, we are going to do the load calculations. So generally for a building, we have a different types of loads. What are they? The first is we have a lighting load, and next is we have a power loads, and the next is we have an AC load. So in our building electrical loads, we have three different types: lighting loads, power loads, as well as an AC loads. So in the lighting, we are going to study about the internal lighting, like how many number of lights we require inside the flat, and then we are going to study about the external lighting, outside lighting also, and lamp selection. How do we do the lamp selection, on what basis, and then how do we calculate the number of lighting fixtures, and then we are going to study about the fans and exhaust fan calculation also. Then we got the lighting load. Now the next load for a building is power loads. Okay, in the power loads, we have a normal sockets which are used for electrical load consumption. Okay, that are nothing but normal sockets and power sockets. So once you got an architecture layout, we need to calculate how many number of normal sockets we require, how many number of power sockets we require. That is we are going to study in the power calculations. And in the AC, mostly we focused on domestic ACs that are nothing but split ACs as well as window ACs. So for a particular room, what is the capacity of AC we require, how much is the split AC we require, how much is the window AC capacity we require. That is we are going to study in the AC calculations. Okay. Now once we have done that, then we have a software which we are going to teach you is, we are going to study about the Dialux software and CGLux. But presently no one is going to use CGLux, because CGLux is a Crompton Greaves Lux, where Crompton Greaves software, where we can do only 2D modeling. As you can see in the image, we can do only the 2D. We can't see the 3D and we can't see the visualization of light and all. But when you're going with the Dialux software, as you can see in the image, we can do the total 3D modeling of the room, and we can place the lights and we can show the impact of light, how it is distributing equally also. That is the most important, that we go with the Dialux. So in the models, we are also going to teach you about the Dialux. Okay, so that's about the load calculations and the specifications. Now, so that's about the load calculation second model. Now when you see the third model, in the third model, what is that we are going to study? In the third model, we are going to study about the load. So in the second model, we had finalized the load, we had got the total load. Now once we got the total load, we need to balance the load equally in three different phases, because in electrical, the most important topic is load balancing. So we are going to study about the load balancing. So when you are going with the load balancing, we are going to do the first lighting load balancing sheet. The next we are going to do the we are going to do the total load balancing sheet, and then we are going to do the DB scheduling and analysis. Once we got the DB scheduling analysis, we need to go with the SMDB load analysis and the MDB load analysis, because once we got the total load, we need to balance, and after balancing we are going to study the total load of your DB load scheduling and the sizing and SMDB and then MDB, and these are the internal. Now when you go with the external of your flat, we have a motors. So for motors are all connected to MCC panels, like motor control center panels, in which we have a lift motor, water motor and firefighting motor, and the motors are all inductive, so we need to increase the power factor. So to improve the power factor, we are going with a panel called APFCP panel, that is automatic power factor correction or control panel. So we are going to study in depth about that APFCP panel. So next one is, we are going to study about the load flow drawings. So we need to prepare the load flow drawings also. Like you can see, once we have done the balancing sheet, first we need to do the load flow drawings. Load flow drawings means from the distribution to which room, how the phase is going to distribute. Like lighting, okay, for a room entrance, all a room light is there, which phase is coming to that, okay, how the lights, how the power supply is going to distribute it from the DB to the switchboard and from switchboard to the points, how it is going to distribute it, that we are going to study. And when you see the total single line diagram from the point of supply, when you see the point of supply, from the point of supply PT, CT, then next we have a main distribution boards, and from the main distribution board we are going to put a sub-main distribution board, and from the sub-main distribution board it's going to the distribution board. So when you see the load flow analysis, we are going to do this all things, individual single line diagram and the total single line diagram we are going to study in the drawings. Okay. Now when you see the connection, as you can see, if it is a single phase, like if you have a single phase DB, how the connection is given, like you can see an example, we have the main supply which is coming from the pole, and we also have a generator, then we have a changeover circuit breaker. Okay, we have a changeover circuit breaker here, so that whenever the main supply is there, then the main supply is going for the building. Whenever your main supply is not there, then we need to change over the supply to the generator. Now once you have done the change over to the supply to the generator, then we need to supply the power to the distribution board. So in the distribution board we have an incomer, okay, and from the incomer we had taken the supply and we had looped all the in the bottom, and the neutral will go to the neutral link. You can see in the bottom we have a neutral link, and right side we have a earth link. So how the distribution is going on, which circuit breaker is going to which rooms, what is the size of the circuit breaker, cable size, this all we are going to study in distribution board analysis and the load flow studies. Okay, that's about the third model. Now when you see the fourth model, now once we had done the summarization of all the loads and load balancing sheet, now we need to give the main supply for the building. So how we are going to do the main supply for the building, that is the fourth model we are going to study, is electrical load summarization, transformer, generator and the UPS calculation. Once we had summarized the load, we need to give the power supply with the help of transformer, generator and the UPS. So we are going to study about the transformer size calculations, that is power source calculations. Now how do we are going to calculate the power source calculations? With the help of your total connected load. Once you got the total connected load, then based upon the total connected load, we are going to calculate the transformer size. So generally now BTEC we used to have a formula called KVA equal to KW by power factor, apparent power is equal to active power divided by power factor, but that is only a one word answer which helps you, but in a reality we do totally 10 steps to 12 steps of calculation for the transformer. Then next we are going to study about the CT specifications, generator calculations and the UPS and the battery bank calculation also. So once we got the UPS itself is not enough to give the supply, but for the UPS we require a battery, so we are going to study about the battery banks and the age calculations, and then we are going to study about the CT and PT also. Okay, so you can see types of transformer, we have power transformer, distribution, instrumentation transformer. In detail we are going to study about that. Now when you see the last two models, that is electrical design calculation and building protection system design, routing and connection, what is that we are going to study in this electrical? So we are going to study about the calculations related to circuit switch case, like voltage drop and short circuits. So like you can see vacuum circuit breaker, we have A circuit breaker, we have MCCB, we have, and then miniature circuit breaker. So which type of circuit breaker where do we use? So now when you see the total calculations related to this, so in that the first is we are going to calculate about the circuit breaker sizing. Once we are done the circuit breaker sizing, the next topic is we are going to do the cable size calculations in the electrical design model, because for a particular load if you want to put a cable, we need to calculate the cable based upon the parameters where you are laying the cable in ground or air. Considering all this parameter based upon the number of runs and the current carrying capacity, we need to do cable size calculation, and then we do circuit breaker size calculations, and then we perform bus bar calculations, and we do cable tray calculations. Okay, till now we are done with the sizing along with the lightning arrestor. We do lightning arrestor calculation also. Now after this we need to do analysis whether your design is perfect or not. In your analysis we have the first one is voltage drop calculation. So you are done the total design, but you need to check the voltage at each and every point. And if when you check the voltage with the help of a multimeter or a clamp meter, you are getting some 110 voltage. So what is the use of your design? It's totally wrong, right? So we need to analysis whether your design is perfect or not before the execution goes on. So that is we do voltage drop analysis also, and then we do short circuit current analysis, and then circuit breaker interrupting and the cable withstanding capacity, whether my cable is going to withstand that much of fault current or not, or whether circuit breaker high is going to trip or not. That is we are going to do the specifications in the analysis part, and then we do based upon that analysis we do the earthing calculation also. Now coming to the requirements, what is that we are going to give it to the client? So we need to give the schedule list also, as well as we need to give the BOQ also, bill of quantity. So for any client, once the designing part has been done, we need to give two things. The first one is schedule list, as well as we need to give the bill of quantity. That is we are going to prepare in this. Next, so coming to the drafting part, in the electrical drafting we are going to study about the drawing layouts, okay, single line diagrams. Then once we go with the first material insertion, like where the lights has to be placed, where the fan sockets has to be placed, and then we are going to do about the conduiting works and the distribution board circuit wiring and the control wirings. And in coming to the single line diagram, we are going to do about the HT scope, LT scope, as well as in double pole structure and the earth pits, how the connections is going on. So overall this total design, what are the model, what are the concept, what are the standards we use? In the electrical designing, we use 4 standards called ISLE, Indian Society of Lighting Engineer, BAS, Bureau of Indian Standards, IEEE, in international standards, and then in National Electrical Code, NEC, we also use NEC. So these all 4 codes we use for designing of your electrical system for the building. That's all.